Good evening, everyone. Let's find something new, interesting today. Have you ever wondered how many map services like Google Maps and MapQuest find directions for you? Let's take an example. If you wanted to go from Sydney to Melbourne, it takes out that the directions are not just memorized. We have to actually calculate them. It turns out that the way we calculate directions use a bit of computer science and mathematics called graph theory. So let's discuss some of the basic graph theories. Today we have a path or graph of hexagon, so in which we have six nodes and six vertices which are represented by vags. Here you can see in the graph, and as a edge, there are seven edges which are represented by the yellow rope. We can see that. So let's talk about Euler path and Euler circuit. We're gonna find these things. What is Euler path? First, we need to understand that a simple path containing all the edges of the graph. In other words, an Euler path visits each edge to graph once. And Euler circuit is a path that returns to the starting point, covering all the edges. And whereas Hamilton path is the path which visits every vertices in the graph exactly once, and which has the other thing, Hamilton circuit, which returns it to its starting position by covering all the vertices. So today we're gonna discuss about something like that. So Chris is doing the video part. Hi Chris. I'm doing narrating. Hi. And Jason is doing Hamilton path and circuit. Jason, say hi. And Ranjit is doing Euler path and Euler circuit. Thank you, Ranjit. Over to you, Ranjit. Can you explain Euler path and Euler circuit?
Yes, so today I'm going to try to find if this graph over here, we can find a Euler path and a Euler circuit. So as you can see, this graph here has six vertices or nodes, which we have represented by bags. And we have seven edges, which are represented by these yellow lines. So I am fully allowed to walk wherever the nodes are connected with these yellow lines. So these are my edges. So my job here is to find if I can find Euler path and Euler circuit. So for a Euler path, we have to visit each and every vertices without leaving any. If I can do that, that is Euler path. If I can visit each and every edges and return to the same vertex, then I can find a Euler circuit. So let's get started. So I'll pick this as my starting vertex, this black bag or my node. So let me just walk to the next bag by following the line, the edge. Then I'm going to move to the another edge, then again to the another edge. So now I can walk through this path over here or here. Randomly I'm going to decide to walk this one. I don't know why, but it looks better. Walk here. Then again I'm going to go to this other edge, following the edge to this blue bag. Then again, finally to this edge. Well, as you guys know, this is the edge. This is the vertices that I started from. But I have not completed the Euler path because I have not visited each and every edges. So I do have to follow this edge again. So, what do you think? What just happened? So I was able to find a Euler path, but not the Euler circuit, because I was able to visit each and every edges without missing any of them, but I ended up in two different nodes, not the one that I started. So hence, it proves that I was able to find a Euler path, but not a Euler circuit from this particular graph over here. And, well, if you look at it with theory, we can see that it was not possible to find a Euler circuit because for a Euler circuit, the graph cannot have any end. So, because we have exactly two vertices that are odd, we were able to find Euler paths but no Euler circuit. Hence, we conclude that we are able to find a Euler path but no Euler circuit from this graph here. Thank you.
Thank you, Ranjit. Let's go to Jason for understanding some Hamilton path and Hamilton circuit. Over to you, Jason.
Hamilton paths are when you try to circulate the entire graph. But the thing is, you have to touch every vertex maximum of once, once and only once. So, but the thing is also the Hamilton circuit in which you need to touch every single vertex, but you also have to go back to the starting position where I'm at right now. So, let's start off by looking at a Hamilton path. So, I'm starting at this circuit right here, at the big black bag. And then I'm going to move on to the next vertex, which is this blue bag in the corner right here. I've left that one behind, but that one's touched already, so I can't touch that one again. So I need to go to the red bag here, leaving the blue bag behind, which makes that this one is also touched. And then I need to move on to here. Now, I need to choose either to go in through the middle or to go to the left. So from this point on, in order to make a Hamilton path, I need to go here, because if I go there, back to where I started from the black bag over here, then I've already made a Hamilton circuit, but not really a Hamilton path. So all I need to do is go to this last blue bag here, and then go back to this black bag here. As you can see, I've left no vertices untouched. But the thing is, just consider the fact that Hamilton circuits, Hamilton path or circuit don't need to worry about any edges. You only need the vertices, and that's all. Thanks.
Thank you, Jason.
There's another method. Don't stop the video.
Okay.
There's another method of finding a Euler path. So, like I did before, I started from this.
Ranjit, I need to stop you for a minute. I'm just completing Hamilton path and Hamilton circuit. Thank you, Ranjit. So we can see Jason explained how we can complete Hamilton path and Hamilton circuit. So I guess from this we can understand how are we going with Hamilton path and Hamilton circuit. So thank you.
So why do we study about graph theory? Let's talk about some applications of graph theory. Graph theory started with Euler, who was asked to find a nice path across the 7 bridges, and Sir William Hamilton developed a toy based on finding a path visiting all cities in a graph exactly once. But now graph theory is used for finding communities in networks where we want to detect heritage of substance. It is also used for ranking hyperlinks or by GPS to find the shortest path home. Everything in our world is linked with our links. Cities are linked by streets, rails, and flights networks. Pages on the internet are linked by hyperlink. The different components of an electric circuit or computer chips are connected. Let's talk about some applications of graph theory in brief. The internet, one of the largest graph in the world. Internet displays the best results at the beginning using graph theory. All the social medias, Facebook, WhatsApp, Messenger, Twitter, Google, Instagram, etc. are connected via a large graph using graph theory. In-flight network, for airlines to connect countries and cities in most effective way, they use graph theory. Road networks, design of computer chips to connect millions of transistors that consist in integrated circuits. Computer network security, GSM mobile phone networks, map coloring, and many more. Thank you.